A very good morning to all my dear students. Children, in our last class we learnt about the laws that were put forward by Antoine Lavoisier. We learnt about the laws of chemical combinations. We also learnt about the law of constant proportion or definite proportion. Please, before watching this video, if you have not seen that video, please do watch that because it is somewhat linked to those two laws, children. Okay. So today we'll be learning about Dalton's atomic theory. Antoine Lavoisier had put forward these two laws of chemical combination and law of definite proportion, which proved to be very helpful in actually understanding or supporting the theory which were put forward by ancient scientists like the Democritus and the Leucippus and all. But he was unable to completely explain how the elements were combining, what is it all about matter, about the nature of matter. So during that time, it was a British chemist, British scientist, John Dalton, who actually put forward one atomic theory, which is called as Dalton's atomic theory, which could actually explain the actual nature of matter. Okay, so he also went through all the laws that were put forward by Antoine Lavoisier, also about the basic ideas that were put forward by the ancient scientists, and then he could actually put forward one theory which could solve many problems and answer many questions and doubts related to the nature of matter. So let us just go through this Dalton's atomic theory. Very important examination point of view, also very important subject point of view. Okay, children? So he has postulated few laws. As I told you, he has taken into consideration the two very important laws that were put forward by Antoine Lavoisier. Okay, the law of chemical combination as well as the law of constant proportion. Also there is one more law which is called as the law of multiple proportions. That also he has just studied, and he included them in his postulates. Let's learn one by one. All matter, according to him, everything in the nature is made up of very tiny particles, nothing but called. He has taken that term atom from Democritus, and he used the same term atom in his postulates, children. All matter is made up of very tiny particles called atoms, which participate in chemical reactions. So he told of that, these are the small particles, very tiny particles which compose the matter, which the matter is composed of, and these small particles only take part in the chemical reaction. So he very clearly mentions about the terms atoms in his postulate. So atoms are indivisible. We already got this idea from our ancient scientists, like I told you, Maharishi Kanada and Katyayama. All those, have already put forward this idea. So the same was put forward by Democritus and Leucippus also. That means indivisible. The actual meaning of the term atom is nothing but indivisible. Very small, simplest particle which makes up a matter, and that cannot be divided further, which cannot be created or nor destroyed. So what he said? These are indivisible particles which can neither be created nor destroyed. So can you link this to the law of conservation of mass, children? What did we learn in the law of conservation of mass? We learned that the mass is neither created nor destroyed. Mass is nothing but ultimately it is now the atomic mass of the atoms that are taking part in the chemical reaction. So when the mass is neither created nor destroyed, it directly implies that the atoms which take part in the chemical reactions, they are neither destroyed nor they are created. So that is why there is no increase in the mass and there is no decrease in the mass after a chemical reaction. So it strongly supports the law of conservation of mass. Now, atoms of a given element are identical. Did you see here, children? We all now know the definition of element, but it was then a new thing for them. So what is an element? These are a substance. This is a substance. Element is a substance made up of similar kind of atoms. So if you see H2 or S8, if you see sulfur, it has got 8 atoms of sulfur. 8 atoms make up one element of sulfur. Two atoms of hydrogen make up one element of hydrogen. In the similar manner, we have like P4 if I say. So 4 atoms of phosphorus make up one element of phosphorus. In that way, what did he say? That all these atoms which make up one element are similar. Similar in the sense, he has given two very important explanations here. You can see they are identical or similar in mass and chemical properties. This is the best explanation of the matter here, children. See here, they are identical in the sense not just in the shape or in the size. They are identical in the atomic mass. Mass is same as well as their chemical properties are same. So what is he saying? He already told that atoms are the things which involve in the chemical reactions. Now he also has mentioned that they are identical in mass. They are not just identical in shape and size, but they are identical in mass as well as their physical and chemical properties also. So they have similar chemical properties. If I say H2, so it has 2 atoms of hydrogen which are similar in mass as well as they are similar in chemical properties. Whichever chemical properties, chemical reactions this atom undergoes, in the similar manner the other atoms of the element also undergo the same chemical reactions. Okay, very important point over here, children. If you talk about compound, now tell me, if you talk about compound, a compound has different elements combined, isn't it? An element has similar type of atoms combined. Okay. Atoms of different elements. Does it mean that only one kind of element exists in the nature? No. There are many elements which exist in nature which are different in mass and chemical properties. Did you understand? It's not that only one element is present in nature. There are several elements which are different from one another. There are about 119 elements discovered so far. We have been learning in our textbooks, right? So all these 119 elements are different. Already he has explained, he's given a beautiful explanation of, how the nature of matter, how these elements, what kind of elements are present. He already told that many elements will be present which are different from one another. In what respects are they different from one another? They are different in terms of mass, also in chemical properties. He said no 2 elements will be same. No 2 elements will be same. Okay, they will be different either in the mass, mainly in the mass and chemical properties. Atoms combine in the ratio of small whole numbers to form compounds. So this relates to the second law, that is law of chemical combination, which is nothing but definite proportion, law of definite or constant proportions. So what he said, they combine in a ratio of small whole numbers to form compound. One molecule of one element combines with 2 molecules of other element, something like that, in whole numbers actually, not in like fractions or anything like that, in complete whole numbers to form compounds. Okay, this is nothing but what we learned under law of definite proportions. Compounds are formed when the elements combine in fixed ratio, and that ratio will be always in the form of whole numbers, small whole numbers. So he has given you an idea about the atoms, also how they combine to form elements and how they combine to form compounds. So basic structure or basic explanation was given by Dalton's atomic theory. The relative number and kinds of atom are constant in a given compound. So this is more related to the law of definite proportion or constant proportion. If you take water, for example, if you take water, the relative number and kinds of atom, you can see the relative number. Hydrogen has got 2 atoms, oxygen has got 1 atom, isn't it? So the relative number and kinds of atoms. So this is hydrogen atom, this is oxygen atom. Different types of atoms are constant in a given compound. So if you take water as a compound, the relative atoms are always 2 hydrogens and 1 oxygen combined, and there are the kinds of atoms also are constant. That means only hydrogen and oxygen only you will see in a compound of water. No other element you can see in the water. So this was the basic idea that was put forward by Dalton, children. Very, very important subject point of view, as well as it's a very frequently asked question also. It can come as 3 marks or 5 marks question as well. Okay, so please do, and do not try to create your own sentences for the postulates, children. You have to write as it is, because they are like laws. Okay, so postulates and laws, the statement of the laws should not be like written in your own words. You have to write as it is. So please go through these all and learn them well, and do not just change the sentences. As it is, you have to learn. Then explanation of the postulates, you can do it in your own. Okay, so these are the postulates that were put forward. You can write this, and if you want to explain each postulate, then you can use your own terminology or words that has to be meaningful. Okay, so today I stop here. Please go through this video again in case you didn't understand any point. So let me know if you have any doubts. Okay, thank you.